Welcome, and welcome to all of you. This is SkyTour LiveStream with Marc Dantonio, that's me. And as always, we have Daryl Mason with us. Hello, Daryl, how are you? Daryl? Daryl must be on mute. He's still connected. Well, we'll wait for Daryl. Can you hear me, Daryl? Okay. We'll have to find out what's going on with him. Alright. Well, in any case, we're actually looking at a wonderful nebula here. I can hear Daryl typing, but I don't see him, hear him in the voice here. Okay, Daryl says he doesn't hear me. Oh, that's odd. All right, hold on a minute. I think obviously you guys hear me. So I want to say hi to everybody, but I'm going to troubleshoot this as well. All right, let's just go in and see if we can troubleshoot here. Let's see. That works. That works.
Testing. 1, 2, 3. Testing. Does anybody hear me?
Yeah, I hear you.
Well, there you are.
Yeah, what happened?
I didn't hear you via the...
You must have had your microphone or your headset muted or something.
Oh.
I didn't change anything, and now you're back, so that's good.
Yeah, you sound like you're kind of dropping out even now. I heard you for just an instant when you first started talking.
Okay.
And then you dropped out completely. Can you hear me now?
I didn't stop hearing you. Well, actually, I couldn't hear you before. I heard you typing, though. So that's weird.
Can they hear me?
Yeah, you're going out.
Okay, hello everybody. I hope you can hear me.
They can. I'm watching the signal go out. You're going out.
Okay.
So let's see
now,
here.
You like vanished completely there.
Yeah, I have no idea. But they heard me. They were hearing me say, "Where's Daryl?"
Okay. Looks like they agree with you.
Yeah. So let's see. We're actually doing this is an object that is near and dear to me. I love this object. It's actually this object here. It's
and you just dropped out again.
I'm not dropping out to them, though. It's dropping out to you, but not to them.
I can't hear you at all. I barely.
Okay.
You're clipping really, really badly.
Not to anybody out in the audience, though. So let me figure that out. Let's see what might be a problem. Okay.
I hear you now.
Alright, so let's try something else here. Alright. Can you hear me now?
I do.
Alright. So we'll run with this as necessary.
Okay, yeah, it's like you started clipping out really bad. You kind of got clipped off and then you went away completely.
Yeah, that's only happening to you, though. It's not happening in the stream, in the output audio, so it's something within Skype, I believe. Because a few folks listening, that we go through Skype to actually get our signal and our audio, so that's what you're hearing. Alright, so let's go in here. This is the, okay, first of all, this is the Perseus molecular cloud. This cloud is absolutely amazing. And this is the northern part of it. Okay, so up here, this is all northern. You can see the stars, and you see this faint cloud. This is part of it, and then it gets dark down here. We're going to be heading down there in a little bit. We've got 24 of these stacked. We're going to go to 25, which will be right here. All right, and then we'll pause it, save it. Okay. And we're saving our FITS file, which is our astronomical format. And then we'll save it exactly as seen so you can see this exact file. Okay. So now that's saved, and what that means is it goes up to the server. Right now it's being taken out of the observatory 2,500 miles from here, and is going up to a server, which will then be dropped down for you to drag it down and examine it, look at the pictures, enjoy the beautiful picture, and you'll be able to do it in about 2 minutes from now, maybe less. So that should be pretty cool. Yeah. So
I
this.
think Arson has a question of you.
Okay. What's the technical term for this type of media? Oh, okay.
Nebula.
Yeah, nebula. Sorry. This is as you can see in the title right there. It's actually a dark nebula, right? And dark nebula is not such a technical term either. However, a dark nebula is a nebula that has a lot of material that does not give off its own light. The material in these nebulae will often be reflected light from nearby stars, or light that the dust particles which make up this nebula scatter from blue stars, or the blue component of a star that has blue in its spectrum. So that could give us a reflection nebula like this right here.
Like you call it a molecular cloud.
You don't see the title. It says Perseus molecular cloud on the screen. You don't see that part. But yes, it is a molecular cloud. All right, so what I'm going to do now is I am going to bring this down just a little bit more, because there's a lot of stuff in here that we want to see. Okay. All right, just a little bit more. Alrighty, maybe just a tad. Get rid of that star. There we go. Okay. So we'll go from here in just a minute. So we're gonna do, this will be another 45-second shot like the previous one.
Marianne is here.
Hey Marianne, I thought you were watching Wind River with Randy and Diane in Mesa. Emission, okay, Marson says emission I think would be where the hydrogen, I think is ionized and radiates its own light. Yes, not entirely to the ground state, but to an energy level that's actually at energy level 2. N equals 2 in the hydrogen atom. That's what it goes to.
He said earlier, could have sworn it was an immersion nebula or something, so I thought maybe he meant emission.
He does. Yep. And we'll see some emission nebula. Okay, we're stabilized here. So we're going to go and do our 45 seconds on this other half of this nebula. Okay. Alrighty. So I'm going to clear this, because that's the previous one. And now we'll be looking just below it.
I assume you're going to mosaic this.
Yes.
Okay, so you need to pay attention to your exposure counts and
Yep. I did 25 of the other.
exposure time and gain and all that stuff. Maintain consistency.
Yeah, we're doing it at 400. There's 400 gain. There's the lower part of that cloud. There's that reflection nebula we saw in the past one right there. And we'll just color correct that and give it a little kick. There we go. So then we're going to go to the right and then we'll go up and capture the bulk of this cloud, and then we can mosaic this together. I want to say hello to everybody that's here. And first of all, C&D Boy, hey man, welcome. You were the first one. Vera Lucia Campos from Brasilia is with us. And we have Robin Curtis. Hello, Robin. She is listening from Colorado. And Donald Kunzer. Donald Kunzer, I've got something special just for you. He says, the timing is perfect. I just finished watching the latest MST3K Christmas special. That's Mystery Science Theater 3000. And for those, now it's going to be backwards, but for those who know that show, you'll recognize this. Okay? You know what that is? That's the meteor that you see at the beginning of the show. It's actually the actual one. It was made by a guy I knew who did the prop for the show, and this is the thing right here. This is a copy of it from his mold, so I think that was pretty cool.
I keep doing that for a second. I have to see this.
Oh, sorry.
Okay, I see.
Yeah.
Cool.
Mystery Science Theater 3000. Wow.
Joel or Mike?
Joel first, and then I think Mike, right?
Well, I'm asking which you prefer.
Oh, Joel.
Joel was a little edgier.
Yeah, I like Joel.
Yeah, Mike's okay too, though. Favorite episode? For me, it's Prince of Space.
Oh, Prince of Space was hilarious.
And Deathstalker and the Warriors from Hell. Potatoes are what we eat.
I loved the Crow T and Tom Servo were the funniest little robots. And my friend actually built those too for the show. Very funny. Crow T was a lacrosse mask with a bowling pin. Tom Servo was a gumball machine, which was funny. Anyway, hilarious stuff.
I think they're on YouTube, Izabela. At least clips of them are.
Yeah, for sure.
They go back quite a ways.
Oh, yeah.
Joel was the first host, and then Mike took over.
That's right.
I always thought Joel was edgier, but Mike was funny too.
That's true. They're all funny. Yep, they're all funny. Indeed. Okay, we're still waiting for this. We're at 5 frames exposed. I did the autofocus before, guys, just so you know. So we're going to sit back and let this come in for a bit, which is what we want to do. All right. Let me check one thing while we're waiting here.
Marcin, I think if you don't put it down the drain, you'll be okay. Just let it evaporate. Or if you're uncomfortable with that, just set it outside and it'll evaporate on its own.
Yeah, it won't burst your pipes, Marcin. You first have to freeze the water to do that. And unless you got a really, really large quantity of it, it's not a big deal. You could actually throw it on your lawn, you know, or out the window at some pastures. No, I'm just kidding. It's pretty simple stuff. I did a lot of fun experiments with it.
I have to tell a dry ice story now since he brought it up.
Okay.
Many years ago, when I was still a Ute, our father was the construction super for a Howard Johnson's hotel down in Mobile, Alabama. He was building it. And about once a month, he would come back home. And every time he came back, he made sure to get fresh frozen bay shrimp and packed them in dry ice in an old-fashioned styrofoam cooler.
That's cool.
Put it in the back seat of his car and come home for a weekend. And we would feast on fresh shrimp, fresh frozen shrimp.
Mm-hmm.
And one time in the height of summer, he did that. He had a really nice old Dodge Coronet, if I remember right. It was about a 66 or 67. He loaded up that cooler full of frozen shrimp and dry ice, and he headed back to Missouri. This was the height of summer. And what he didn't know was the cooler sprang a leak during the drive. And the dry ice all evaporated, and the shrimp thawed, and all that raw shrimp juice leaked out of the cooler and soaked the back seat of the car.
Oh, that's into that car.
Oh, it was. He wound up having to sell it. He could not get the stink out of the seat.
Sell it to someone who doesn't have a nose.
Yeah. It's a pity. It was a really nice car too.
Mm.
White, with a light blue interior. That car just, I can't say in mixed company what that car smelled like. But it was absolutely awful. It broke his heart because he loved that car.
Ugh. I don't know. I think I'd be happy hating that car if if I knew, you know, if I knew it was going to smell that bad. So I don't know about that. You know what I mean?
You just dropped out again, Mark.
No, but I said I would hate selling the car, but I would do it if I had to, right?
Oh, yeah. Well, that's what he did. You know, it just, again, I can't say how bad it smelled.
Yeah.
But, I mean, he took the back seat out. He washed it. He washed it many times and scrubbed everything. And
terrible.
It never came out. It smelled terrible. You couldn't imagine how bad it smelled.
Did you have a car like that yourself ever?
Not a Dodge Coronet, no.
Okay, that's a small car too.
It was a sedan, I guess, or a hardtop.
Yeah.
Cool old car.
Wow. All right, so we're still sitting here. We've got 11 in, and we're going to keep going up, figure out what we got here. Okay.
There were a few times at work we used liquid nitrogen to chill great big plane bearings before we pressed them into a machine frame.
Okay.
And, you know, you chill it for so it would contract and it'd be easier to get in there.
Yeah.
These were about 4-inch diameter bearings.
Gotcha. Gotcha. I love these big molecular clouds. What's your favorite dark nebula?
Oh, golly. Horsehead, no doubt.
Oh, I guess that's true. Horsehead is really stunning.
Yeah.
Without a doubt, the Horsehead has got to be one of the most beautiful nebulae out there.
You're dropping out again.
Only for you. I'm not sure what's causing it.
Not my fault.
Okay, well, I'll have to solve it another time. Claudio Ramos, how are you from Chile? Nice to see you here. Jessica S, how are you? Okay, we're at 14 here. Now we're actually making a mosaic, so you know this is the lower part. We're up here. I did this before we started just so they could get a little further ahead. This guy here, this reflection nebula was down here. So I moved it up. We're doing this part, and then we're going to go over to the right and do that part. And why am I doing this? Because I'm giving Orion in that neighborhood of the sky time to come up above our edge of our observatory there. So we want to get that, get the telescope able to see over this ridge of the dome or the building. And I have to do it this way because initially we were planning on putting multiple telescopes in this building, so we had to kind of stagger them. And it looks like maybe this one will be alone in here because we're looking at 2 other possible sites in Arizona for the third telescope. The second one, well, the first one is behind me here, which I've shown you a few times. The second one is, of course, the one we're using tonight, and the third one is the one we will be getting. So that's coming. Nice, okay. Alrighty, now let's see.
Marc said in recent history, for me, it would be Firefly, the TV show.
Well, you got to read his question so people know, because not everybody's reading the chat.
If you have a favorite science fiction story, TV episode, or movie, what is it and why? I would choose Firefly.
Yeah, Firefly was a very good show. Alan Tudyk was in it. And River was it? What's her name? River
Tam?
Yes.
Yeah, that's oh God, what is her name? Miranda Bachman's in it. She's been pretty successful.
Yeah. Right, she was the engineer.
Adam Baldwin.
Yeah. Alan Tudyk was the pilot.
Yep. Shepard Book. He was what's his face from Barney Miller.
Oh, that's right. And then you had Jane.
Yeah, Adam Baldwin.
Oh, that's Adam Baldwin, right? Okay. Donald Kunzer says, Mark, it sounds like you'll need a co-pilot to run multiple telescopes. Well, I actually was sleeping yesterday evening, and at 3 a.m. I woke up and figured out how I'm going to do it. I figured it out, and it just came to me. It's like, oh, I know how this is going to work. So I'll be able to have multiple connections to the different buildings all at one time, and I'll be able to pick off the different screens and put them out in the display software. Like here, you're looking at a broadcast window. This is a whole broadcast window system you're looking at, and I've placed these windows specifically here to do the particular jobs they do. And like as you know, we can actually say, okay, well let's just make this bigger. Okay, we can do that. We can increase the size of this. We can actually get rid of this guy, and now we have the entire screen full of our thing here, and it can actually remove the name. So pull the name out of there for now, and now we have a whole sky full of the Perseus molecular cloud. Right, and you don't see it, but I do, and it tells me that we have 20 stacked so far when we're looking at it in a full screen like this. This is the camera control system. There's no more data over here. This is the edge of the frame right here. Okay, so there's no more data hiding behind this. Okay, so
I don't see your telescope controls tonight.
Well, I just got rid of them. See, watch. I'll bring it back now. There it is.
Okay.
There they are.
No, I believe you.
Yeah.
You're just showing everybody the big picture.
Yeah. Hey, Sam S, how you doing? Hey, Saren Man, how you doing? Saren Man, what's up? Expanse is very good. I've been watching The Expanse. and have been for quite some time. The Expanse is a really good show. The reason I like The Expanse in particular is because they have belters, asteroid miners. I wrote a short story many years ago when I was actually in university getting my degree. I would pass the time by writing short stories, and one of them was an asteroid belter named Marc, and he had a little sidekick that would help him. Alpern was a little droid kind of thing, but a humanoid droid, but looked like a machine. And he and Alpern were having all these fun trips. I made Ceres their home base, which is kind of funny because that's what it is on The Expanse. Really neat. Great minds think alike, right? Ha ha ha. Yeah, The Expanse is good. Yep, without a doubt. Indeed, indeed. So,
Bullwinkle asks what defines a molecular cloud.
Oh, that's a very good question. If you look in this picture here, you'll see there's some really, really dark areas and there's some lighter areas. But notice the color. The color is sort of a brownish, isn't it? Okay. Well, that brownish color is related to the silicate materials that make up these silicate molecules that make up these clouds, along with carbon molecules. These are elements forged in the heart of massive stars, and when that star went supernova, they were spread to the universe. Now you see the size of these dark clouds throughout our galaxy, and you say, that's a lot of supernovae. How could that possibly be? Well, it is. And now the dust out in the middle of the interstellar medium got there somehow, and it got there through these massive supernovas, which is telling you that there have been a real lot of them. Now, the universe has nothing but time on its side, and humans have a hard time fathoming what 1,000,000 years is. In fact, humans can't even envision 1,000 of anything. Okay? So, that is a limitation of the human brain. We did not evolve to need the ability to understand what 1,000,000 of something is, 10,000 of something is, even 1,000 of what something is. We cared about what we had in our immediate perceptive range. And so that's the reason why we don't have a good grasp of numbers. And that's why when you see this dust and think, holy cow, that stuff is literally out there, how could it possibly have been generated by stars? Because you don't understand the time frames of the universe. If you knew the time frame, or you had a good feel for it, you would understand that there was plenty of time for this dust to be made and dispersed through the interstellar medium. So that's what's in these clouds. Now, it's not just carbon and silicon. It's actually a lot of other materials. There is methanol, carbon dioxide ices, water, hydrogen, oxygen, and ammonia, and other materials. So there's a slurry of materials in here that make up this cloud. Okay, we're done with this guy. So we're gonna.
One other thing you could say is they're cold.
Yeah, that's true. They're actually very cold. I'm gonna save this, and we're gonna save just a scene. All right, and we'll get rid of this stack because we don't need it. Go back to our night vision mode, which is right here.
That reminds me of something I saw earlier tonight.
What's that?
Maybe once you get the next image rolling, I'll talk about it.
All right. So now we have our reflection nebula up there. We're going to bring it all the way out here. We're actually going to bring these two stars and that star all the way to the left side. All right. So to do that, I have to take us and run us to the west. So here we go.
Owl's no move. There it is.
Yeah. All right. So again, we're moving these two stars and this star all the way to the left side. If you notice, the time is frozen here. We're actually just waiting for the Starlink satellite. Sometimes it happens. And we'll reach some points where it'll stall out, it seems, you know. But that's just what happens with this. Okay. That's good. Gives us enough overlap. Alright. Okay, so that's good. You notice where you see stars here? That's where there's no dark nebula. There's a lot of dark nebula all in here. That's why you can't see it. Now our star lock is locked on. You can see the guiding has begun right there, up there. And so we can now set our 45-second time frame again. And we'll do 45 seconds. And go. We'll come out of night vision and go back into the live stack. Doing our live stack here. And we'll clear this stack, and you'll see that these two stars are not going to be over here. So we're going to go into our live stack, clear it, and I'm going to bring it out of hidey mode, so it actually does this. Okay, and we'll see it right now. James Dugan, how's it going down there in Australia? How are you? It's good to see you. Cosmic Ray, hi.
Okay, per what I mentioned a minute ago, you're talking about molecular clouds reminded me. Evidently, there's a new or very recent Hubble image where they captured a small irregular galaxy that had been hidden behind a foreground star. And this star has a high proper motion, I guess, or it's moving fast across the sky. Mm-hmm. The star has recently moved to the side and has exposed this galaxy. I think they're calling it the Hideaway Galaxy because it was hid behind the star.
Neat.
They said it's like 20 million light years away, so it is close to us, relatively close. Yet the galaxy's behavior is very much like a galaxy from the early universe. Something that would have been many billions of years ago. It is a metal-poor galaxy. It doesn't have the higher elements, you know, it's just mostly hydrogen, they said. And yet this galaxy is only, 20 million light years away from us.
Yeah, that's one of the other things, too, that is an interesting factoid about our galaxy, is that we know we have the Large and Small Magellanic Clouds, and we know those are two dwarf galaxies that are orbiting our own. But did you know that the Milky Way also devoured another dwarf galaxy in the past?
Sagittarius dwarf?
No, it's the Eridanus. Oh, what's the name? Darn it, I had it in my head. I just looked at it. Huh?
Eridanus?
Yeah, it's the Eridanus. Or you can call it that. I call it Eridanus. But yeah, there's a galaxy, an Eridanus galaxy, dwarf galaxy, and it was a galaxy that we devoured and subsumed, and we added like 50 billion stars to our galaxy when this collision occurred, and we added several tens of globular clusters to our galaxy when this happened.
There have been a number of dwarf galaxies I know that have been either totally taken up by the Milky Way or they're in the process.
Yeah. But this one is one that added substantially to our mass.
I think I'd read about one in Leo recently. Leo dwarf galaxy or something like that.
Alright, we're waiting for this guy. Look at this beautiful clouds of dust. This is a magical location. And you guys know that dark nebulae are my hot button. They are the incubators of stars and planets. Everything we know in the universe was born in such a cloud. Now this cloud is not just dust, not just silicon and carbon and all these other materials I mentioned before, there's also tons of hydrogen in here. Much hydrogen, very much. So this makes it so that a star can form inside this cloud as well as a planetary system. And we'll see that happen. Remember, hydrogen is the most prevalent material in the universe. There's more hydrogen than any other element. Next is helium, and then after that, oxygen, oddly enough. And then the fourth most abundant is us, carbon, made of carbon. So the carbon is the fourth most, and that's really amazing too. Let's see if we can pull this out of the way. There we go. So now we can see a whole river here.
When the elements first formed after the Big Bang, I know they say it was hydrogen plus a little helium, and I think they said back then usually the third most common would have been lithium, wasn't it?
Yeah.
Where did the lithium go?
Lithium was highly unstable, so the lithium isotopes would just decay to something next, or previous. So the decay rates, we could discuss those at some point if you want. I can't tell you the exact decay rates, but I do know that lithium wasn't stable, so we don't get a lot of it. I mean, we do see it in some of the stellar processes, and it's there for a split second, and I mean a split second, like a millisecond, would be a huge amount of time, considering a star and the processes. And we're talking about decay happening in way less time than a millisecond. So that's the thing that makes it interesting, and so
that might be a good subject for a radio episode.
SkyTour radio. Yeah, I was thinking the same thing. Yep.
But then I will ask, the lithium that like we have here on Earth now, that's going into batteries and stuff, where did it come from?
Where they mine lithium?
Yeah, I mean, if it's not primordial lithium, it must be a result of other nuclear processes, I would guess.
Well,
break down other elements or something.
Yeah, and don't forget that's lithium, of course, is not a hugely abundant material. So when we're talking about the contents of the Earth, that's a minuscule amount of lithium compared to the rest of the elements that are abundant. Compared to iron, well,
yeah, well, I know
lithium is almost non-existent.
It's a rare earth element.
Yeah. Yep.
But it's still left over from the Big Bang.
Yep. I mean, obviously some of it did survive, right? And so when the Earth differentiated, and we got these veins of material, we got a lot of gold too. And gold apparently, in some of the latest thinking, has only been created with the collisions of neutron stars.
Yeah, I know that's popular thinking nowadays.
Well, yeah, and there's a reason why. And so the creation of gold, then you say, well, how can we get so much gold in the Earth? We don't have a lot of gold on the Earth, actually. It's quite rare comparatively to the other elements, and that's the thing we have to keep in mind. In comparison to other elements, that's a very minuscule amount. That is why it's so valuable. Can you imagine if our money was based on an iron standard? I have a meteorite back there worth probably $50 million, right? Or whatever. Actually, probably be worth about $1.50, if it was an iron standard, because it would be everywhere. You have iron everywhere.
Yeah, well, I know at one time, are you keeping track of your count?
Yeah, we're only at 10.
They used to say that all the gold that had ever been mined on planet Earth would fit into a swimming pool. I'm sure that's not the case now, but it's still, it is still very rare.
Don't forget that. Yes, that's true, but don't forget that the gold in Fort Knox would certainly fill more than a swimming pool, and that's just what's in Fort Knox. Well, what size swimming pool?
Like an Olympic-sized swimming pool?
Yeah.
It was a long time ago, and I'm sure, I know they're still mining gold to this day, of course. And they found more than there used to be, but it was never very much. Uh,
That's right.
I'd have to go look that up, see if I could find the figures.
Let's find out here.
Anyway.
That's okay. It's neat stuff. Okay, I'm trying to find the details on this dwarf galaxy that we absorbed. It was about 3 billion years ago. I have to give up on searching because I'm waiting here. We got 12 stacked here. Again, reason we're doing this is it's going to make a really neat image, but we're also doing it because we're waiting for Orion and to be able to image some of the Orion region as well. That's going to be the coolest thing. I mean, just like the other night, which we did. Izabela, the radioactive elements are created during supernovae, and I wish that I wish I could bring this up. I think I can. Let me see if I can find it, Izabela. I have a periodic table that shows all of the elements that are created in different processes. And I think that's what you're looking for, or would like to see, I would think. Let's go see, shall we? Stream. That's right.
Best estimates currently available suggest that around 205,238 tons of gold has been mined throughout history, of which around 2/3 has been mined since 1950.
No.
If every single ounce of this gold were placed next to each other, the resulting cube of pure gold would only measure around 22 meters on each side.
Well, 22-meter cube.
Yes.
Okay. So that's bigger than an Olympic-sized swimming pool by far.
Yeah, but maybe not a lot. Maybe 2 Olympic swimming pools nowadays.
Well, 22 meters. I mean, that's. We're talking. You know, you're talking over 70 feet.
Yeah.
In depth. Olympic-sized swimming pools are about 12 at the most, and that's only at one end.
Well, I mean, a cube 70 feet on a side, still, in the big scheme of things, that's not very big.
No, but I'm not saying it is. I'm also doing 3 things at once here, so sorry. Trying to find an image that's going to put all this into a good perspective for you. Not you, but people. Where's that thing? We're still waiting, guys. We're still waiting to get this in here. Actually, there's one thing I can do while we're here. I'm going to do another color correction. There we go. So that shows up better now. With the color being corrected, you can see now the brown clouds. This is going to make a beautiful 3-dimensional image, pretty much. This back here, notice this haze? This is probably a reflection nebula that will come out and be showing, so is this and over here. And we'll see a separation in here, most likely, once we do some processing later. Well, not bad. And what I really like is that we don't have a problem with our guiding anymore. We had some issues with guiding, but we can go minutes on end now and not have any issues with our guiding. So, but look at that. See that these things turn me on no end. These dark nebulae in here. I know this looks like a void, but it's not. It's actually a darker, higher density nebula. You know, the thinner ones are out here and here. There's stuff throughout here. But these are the dark areas. This is where it's happening. It's where stars are forming and where planets will be forming.
The cloud you pointed out up in the top left corner.
The Barnard number?
I don't know. Can you zoom in on it?
Yeah, we can probably do that, huh?
Don't mess up your shot.
It won't.
Well, I was wondering, there's that one reddish star in the upper right-hand part right there. I mean, that might be foreground, but my first thought was that might be in or near the cloud.
I think it's probably in the cloud. If you look at these other stars, there's many stars that are reddened by dust, and so we do see stars that are reddened by dust. Also notice the subtle color difference here. Do you see this? It looks reddish. That's because the hydrogen I told you about is being ionized by yet other stars we may or may not be able to see. This is actually all red emission nebula in here, okay? And then this is dark nebula that's in front of it. When this gets processed out, that's going to be phenomenal looking. You'll see it very, 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 brightly. It'll look like a really gorgeous painting. See how this is red and how this is brownish? Yeah, that's the dust versus the gas. Okay, emission, hydrogen emission. Then you see dust here that's causing a slight reflection nebula, which is the dust is scattering the blue light from nearby stars. It's really amazing. Hey there, Papa Tom. Nice to see you. And hello to our Asian friend. I don't know how to pronounce your name, or I'd give you a shout out and say hello. But if you can spell your name, I would love to know who you are. Alright, we're at 21, and I'm going to, first of all, I'm going to bring back the telescope here. Just move that over. There's the telescope. You can see it's looking almost straight up, so this is going to be one of the better views of the cloud that we can get, because it's actually aiming up through the least amount of air mass, as we call it, or air, if you will. You can see satellite trails here that are fading. Actually, this little weird looking thing might be a glow from the amplifier, and this is a satellite trail that is fading out little by little. Judy M, how are you? Nice to see you. So, another thing too, Daryl, is that the lithium, for the lithium to be around, it's not pure lithium that we find in the crust. It's actually a compound that has lithium in it. And what we have to do is extract the lithium from it. So, we're going to see compounds of lithium in our crust. The compounds are obviously more stable because they have a bonding sequence. There is a bonding energy that they have, and they will be a stable compound. And that's what was made with the Earth when the Earth was made, was this compound of lithium. But the lithium from the Big Bang was not at all going to be sticking around for any period of time, because it's unstable, as I mentioned. So it's just milliseconds and it's gone. So if it bonds in that period of time with something else, well then we would get something long-lived, because that compound will stick around for a long time. All right, we are at 24. So let's pause it and save this. And then go do our last one. Okay, this came out nice.
Last one you'll be going up, right?
That's correct. As I started up at the top left, and look at that. Look at this. This is going to be stunning right here. Look at that, guys. This is the Purchase Molecular Cloud, and man, this is great. All right, so now these 2 stars that we moved over there, we're going to move all the way to the bottom. All right, so to do that, we're going to go back to our night vision system. All right, and we'll do that right now. And I'm also going to get rid of the stack. Actually, I'm going to move the stack, dock it up here, get rid of the stack, and go to the night vision mode, as I said. There we go. Now these 2 stars, we're going to move all the way down to the bottom here. There they go. A little more. Mary Kaczynski, how are you? Okay. Go down just a little more. And I'll do this to keep overlap. JSCO 77, thank you so much. Is that Ji Kaying? Let me know. Okay, we're stabilizing. And we're going to go to 45 seconds. And here we go. All right. And now we'll come out of this and go into our acquisition phase. Look at that. Beautiful. That's going to be so stunning, Daryl.
Mm-hmm.
My God, that's beautiful. Look at that. Wow. I almost don't want to clear it, but I know it's out there. So if you want to know where all this stuff is, guys, it's actually pretty simple. You go to SkyTourLive.com, and SkyTourLive.com is our portal into every image we have here. SkyTourLive.com, and you scroll down and you'll see a link that says "Take me to great pictures," and it will take you to the online server that you are free to take down images from. If you do that, note that in SkyTourLive.com there's also instructions on how to access them. There's the top of the cloud. There we are. Alright, so you'll get the instructions there as well.
And Izabela posted a direct link to your server earlier.
Oh, there we go. And she's got SkyTourLive.com.
SkyTour Live posted now.
Thank you, Izabela. Izabela Melamed is from Sofia, Bulgaria. She's an artist, a brilliant artist. And she's also someone who creates all of the table of contents for you for all of our streams. So please give her a shout out and show the love, because she is amazing. You know, right now she's smiling, going, "Oh no, yes, Izabela. You have to take the praise because you're worth it."
If you look at the reddish dark cloud in the lower left, if you look at the upper right portion of that lower left dark cloud, I see star lines, curved lines of stars, and some of them are almost like parallel lines. But as usual, I wonder if those are real or just happenstance.
Not sure.
If they seem to follow each other, I'd almost think that they're real.
Yeah, and
Like, are they denoting a contour in the cloud itself or something?
or are they just a happenstance because there's so many of them that our eye looks for straight lines, and if you look at them carefully, are they actually straight lines, or are they not quite straight, but your eye is straightening them for you? That happens too. Like this line right here,
Yeah, well, these are curved lines, which is
okay.
the one thing that makes them kind of stand out for me. But I read what you're saying. I mean, the human mind wants to play connect the dots.
Yeah, we do.
It's pareidolia.
Yeah, now, look what's dead center in this image. I'm not sure if that's a galaxy. We'll have to see.
Little fuzzy red thing.
Yeah. So if we actually go over to where our telescope is, alright, and so if you look at this, you'll notice that it's on an angle, okay? So this is north, this is south, kind of a thing, right? Don't be confused by these lines. These are just the lines above the horizon. These are the lines you want to see. North is up there, south is down there, and so we're in this cloud. And if we come back here, okay, there's the star that that's the star that is just below center in our view right over here. That's the star. And we also have something up here. Now we don't see it because I have to bring in that catalog, and I'm not sure where that catalog is yet because I don't know what it is. Maybe it's a sharpless object. Maybe it's not a Barnard object. It could be a Vandenberg. It could be a Melot as well. We'll try. I'm not sure. And it's not a galactic cluster. That's a colander. All right. So let's see if it shows up with any of these that we know. No. So it's something. Well, if let me zoom in first. Yeah, it's not. It's not in those catalogs, or it would show up. But that object is probably a galaxy. Yes.
You marked Barnard objects, didn't you?
I did.
Didn't you think that dark area now at lower left? Earlier, didn't you say maybe it was a Barnard object?
Yeah, let's go see what it is. If it is, it'd be down here. Down below in our...
There's a lens dark nebula, isn't it? Or a couple of them?
Yeah, hold on a minute.
No, that's the wrong side.
Let's just zip it in here. That's Barnard 3.
Okay.
Right there. Barnard 3, that's this guy right here.
Alright.
I knew it was a Barnard object. There's our fuzzy little dot. Oh, wait. Oh, that's not... Okay, that might be this guy right here. That might be a LBN 749. It might be a small H2 region. That's what that is. Very cool. See, guys, that's what we like to do. So we don't just show you pictures. We actually show you what these things are and where they are in the sky. So if we back out here, okay, this is where we're looking. We're actually, if you look down below, you'll see that we're looking to the southwest. And if you go north, okay, you can see that we are in the sky. We're leaned a little bit south-southwest, and we're looking right at a cloud. It's more, It's more. It's so high up. It's kind of. It's north. It's in the northern sky. So look where the telescope is. It's pointing right up and just a little backwards. So it's more toward the northeast to the southeast, actually southeast, southwest. Again, we have our coordinate system here. Now you can see many more objects because that's I brought those in data-wise. So we've been looking throughout this whole region. There is our whatchamacallit, our reflection nebula around Attic. And then we went down here to look at the nebula down here. Then we took an exposure over here. And then we came up here and went here. And I think we're going to do the Embryo Nebula right after this. The Embryo Nebula will look beautiful. We're not far.
Izabela, yes, I think so. Marc could confirm that.
What did she ask?
Is this the fourth image of the Perseus Cloud Mosaic?
Oh, yes. It is. It is. Yes, you're right.
It is the upper right panel then.
Yes, it is. Yeah. And we just have a few left. We've done 10, 11, and so we'll move forward. And after this, we'll go to the Embryo Nebula, which is a little down this way. The Embryo Nebula is really cool. It has a remarkable amount of detail in it for its size and what it is. Remember we did the Embryo and saw how cool it looked? Well, that was a long time ago when we were getting our telescope system operational and set up, and I didn't really have a full what's the word? Handle on all the capabilities that we had. And now I have a much better handle, and we can do longer exposures.
Right near your pointer on the screen, you've got it's almost like a black on black. The dark area right there, and then another smaller one down below it.
Yeah. That could be an actual void in this light dust. See how this light dust is? And this is, as I see it, it's an emission nebula, a small one within this dust. So a star was born in there. Wow. Let's go here. Let's try something. Move this up a little. Okay, see the blue fringe? That blue fringe is very likely reflection nebulae from the blue light from the stars being scattered. And then this stuff is the dust mixed with hydrogen gas. And that all comes clear once we actually do some more processing on it. And it ends up looking really interesting. And so, to see what it looks like, let's zoom out a bit, and then I'll show you what we have in this entire scene. So there is our view, and I'll kick up the shot so you can see. Here you see all this dust out here. Look at all that dust. Okay, here is the Perseus cloud. Here is the darker area that Daryl was showing you and talking to you about, part of it. And you can see how the dust is literally through more area than not in this view. That's the way this molecular cloud is in general. So this is way overblown and isn't usable at that type of brightness, because then we lose the ability to process, because the more we push that in and bring those things, bring those details out, the less latitude there is to move around and try to make them look more presentable. Okay, the light areas will be overblown, the dark areas will be, lighter, and then, as you keep doing that, you throw away more and more and more data. So we try to maintain as much data as we can, keep as much data as we can as we do this.
Ugh, excuse me.
What was that?
That was a yawn.
I know.
We got a late start tonight. I feel like going to bed already.
You can if you wish. I'm actually, like I said, I'm doing this because I wanted to catch another glimpse of Orion tonight before the weekend began.
No, hopefully I'm good for a while.
All right. Hello,
I'm good.
Fantasy. Hi there, Prow. How you doing?
Break away in a few minutes, though.
Yeah. Tell you, we're rapidly building a network of really, really powerful systems. I'm really, really happy with what we're getting for results. Just stunning stuff. Here we go. That pulls back some of the detail a little more. Look at that. So you see the fringe around here. That fringe is, again, probably reflection nebula. The scattered light of blue stars by the dust in this cloud that you see here. And then some of this stuff is going to be red emission nebula that's lingering throughout in the background. So that's neat. Let's see if we can punch up some red. Yeah, we're seeing more red.
Getting pretty daring with that red nowadays.
Yeah, well, you can see now how it really works to our advantage. It helps us see things. Really nice. It's funny, I just looked at the image and I saw what looked like a straight streaks of stars here. And in fact, they're just random stars that I put together mentally in my brain. Made them into streaks. Izabela says, is Casper the Friendly Ghost in the sky already? Yes, it's in the sky. It's northeast of Orion. And that's one of the objects I wanted to take a picture of tonight. We're going to go from here to the Embryo Nebula, and then we'll be able to see the northern part of Orion before we can see the southern part of Orion. So we're going to try and see what we can do about that. And
Didn't we try to
Go ahead.
look at Casper the other night?
No, it was there. We ended up going to the Rosette instead.
Oh yeah, that's right. I remember now. You were on your way to Casper, and oh heck, I just got to go over here.
That's
Look
correct.
at this.
Yeah, I noticed that it was available. Let's go see where we are. Okay, so back out a little bit. We have how many exposures? We have 20 stacked. We have 4 more to go. So while we're waiting, let's go check out where we are in Orion. Okay, we have the Taurus dark cloud as well. But we're going to do the Embryo Nebula after this. You're going to love the Embryo, guys. It's just such a phenomenal looking combo item. It has a lot of different structures that are very, very, very noticeable. Alright, so this is Auriga over here. Right there.
See how far back to the west Mars has moved? Mars was up actually outside the tips of the horns of the bull.
Yep.
And now it's retrograde motion because we just went through opposition. It's moved that far backwards in the sky.
That's right. Looks wonderful. I like seeing how it moves. Alright, so we're up here, and we're going to go look at the embryo next after this. But where we want to go is down here into Orion. And the place we want to go to in Orion is right up here. Let's see. It may not be this one. No, I think it's up here. Oh, we'll find it. Okay, is that? That isn't it, of course, but... yeah, lowers nebula. Alright, let's get our... okay, this is our last image for this, and then we'll be done with the Perseus dark cloud. Izabela asks, how's my computer behaving? It's not. It's making all kinds of trouble, but luckily, I have a temperature monitor going as well. Luckily, it's been staying stable. I did have a problem with it earlier today where it just didn't want to start up. Once it starts, I leave it running. I don't touch it. And it's fine. Alright, so here comes the last one. Alrighty, we got this last one now. Dock it, and we'll say pause, and save, and then save exactly as seen. And that's all going to this directory right here. It says Perseus Cloud Mosaic. Alright, and that's what you're going to be looking for on the database. Alright, in fact, that's the only directory up there right now. If you go there right now, you'll see it. Again, SkyTourLive.com. Scroll down till you see Take Me to the Beautiful Pictures. You go in there, boom, there it is. Gabriela Basso, how are you? Orion, one of my favorites because you can spot it easily. Yes, that's right. Also, Ursa Major. Long time no see. It's very nice to see you, Gabriela. Okay, so here we're done, and we're going to go back to our 1 second shot so we can go into night vision mode. All right.
You're going to the embryo now?
I am.
Okay, pardon me while you do so.
Okay.
Be right back.
Be right here. Okay, so now let's go over here and find the embryo again. There it is. There it is. Yeah, I think you guys will like this. So we're gonna go to the embryo nebula now. And you'll see the telescope move a little bit. You'll see the star streak as we go there. Yeehaw. And here's the embryo. And we'll let that settle out. I have the telescope set up so I can just tell it to go anywhere in the sky and it knows where it's going. You know, I mean, that's the minimum. You should be able to do that. Alright, so we're going to bring this south a little bit. So the telescope's looking down in the sky a little bit. And then we will come right about there. That's right. And head a little to the west. You can already see detail in here. Alright. There we go. Let's make sure we're near center. Very good. Alright. That's very good. Okay. Alrighty. Now we're going to let it, again, you see searching, and then it does the calibrations, zeros, and now it's guiding. And we're going to let the guiding stabilize. And then we're going to go do another 45-second photo. Okay, guiding looks stable now. And we're gone. Off we go. And this is the last photo we took. Perseus dark cloud. Wait until you see this all processed. It is amazing. Then we'll clear this now. Go off. Hey, Brigitte, how are you? Nice to see you. Love light, Nova Gaia Earth. I've done some work for the Gaia network, actually. Okay. So here comes the first image of the embryo nebula coming up. Oh, yeah, look at that. And it is just an amazing location. Wait until you see this all detailed. It is just incredible. This is an emission and reflection nebula. And so I can fling that out there now for you so you can see it. There it is. Let's do a little quick processing on this to make this look better. And when the second one comes in, you're going to notice that a lot of this modeling and noise goes away. See the little color noise? Watch what happens now. Ready? Watch this now. Here it comes. Watch around here. Boom. See that? See how much clearer it suddenly got? That's because we're taking one image, then a second image, and aligning it with the first, and then stacking them on top of each other, over and over and over. So we make an image sandwich of these stacks. By doing that, we get rid of this random noise that occurs in the digital system. And we only get the data. If that data is a dark nebula, then that dark nebula rises to the top. See, that's how it works. There's the embryo right there. There's dark nebula here. There's reflection nebula. This is gonna be stunning. Go ahead.
You said we've seen it before. I don't remember this.
Oh yeah, we did.
That's very intriguing looking. I notice you're running at a higher gain again tonight.
I am. Cosmic Ray says, so much sky and we image Orion 400,000 times? Ray, what's up with that? Come on, Ray. It's coming up. What do you want us to do? You want us to image tiny little H2 regions that the massive amount of people won't be interested in? What we're trying to do is hit the big ticket items so people can sit there, explore, and say, wow, the universe is so cool. A tiny little nebula won't do it for them. A massive Orion nebula will. A beautiful Barnard's Loop will. You know, a California nebula will. A Perseus molecular cloud, which you just sat through, will as well. You know? And Izabela says the Perseus mosaic is actually perfect. Thank you, Izabela. I gave Izabela a program to actually mosaic all of our images right away. And I think that she's used it to do this. Very good. Send it to Daryl, and I'll take it from Daryl, and I will show it to everybody, so people can see what's coming.
Okay.
Yeah, I mean, she can't put a link in here because if I follow the link, I have to screw up my chat. I don't know why that happens. Here, we know what this image is now. This is the embryo nebula. We'll pull it out. Thank you, Cosmic Ray. Yes, Izabela says, this embryo is so promising. Yes, it is, because it has multiple segments within it. And these segments are emission nebula locations with a reflection nebula. Reflection nebula is misnamed, I think. Okay, again, you have a hot star in here with a blue light in it. Okay, the blue light is actually being scattered by the dust in here. All stars are hot, of course, but the blue light in here of the star's spectrum is being scattered, which is why we see this bluish haze. And the scattering process that creates this bluish haze is the same scattering process that the molecular composition in our atmosphere does to the sun's light when it comes in. So That's why the blue light from the sun's spectrum is also scattered, and that is why we have a blue sky. Oh, thank you, Daryl.
Uh-huh.
All right, so let's bring that up, and that's not bad. Holy cow! Okay, good.
That's great, Izabela.
Yeah, that's a nice job, and it's as close as I could get it. All right, so here it is, guys. I'm going to show it to you right now. Okay, let's pop that in. Okay, this is the mosaic we just shot just a moment ago. All right, so you can see we started the upper left, we did the lower, we went to the right, and then up again. And there you go. That's the Perseus cloud, and we're gonna crop it and make it look pretty and do some more processing to pull out more detail. But this is gonna be stunning. So I just thought that was pretty cool. Thank you very much, Izabela, for doing that. You can't beat a good mosaic, can you?
You got your overlaps pretty close.
Yeah. I was going by the stars, the particular stars that I was going to start and end on. So the overlaps were pretty close. You know, I could use a program to actually do this and to actually do it perfect. But you know what? You wouldn't get to see anything then. You have to let the program do its thing, and you sit back and twiddle your thumbs, and it says, okay, done. What do you get out of it? You get nothing out of it. So I'm not doing that. I much prefer to just I much prefer to just show you what's going on and do the overlaps myself, do the mosaicing myself. Look at this. Now you see detail in here. Look at that. Look at this beautiful area right in here. This is stunning. Oh, thank you, Izabela. She says she loves helping with these mosaics. Look at that, Daryl.
Uh-huh.
That's really nice.
Yeah.
This is also, remember we just talked about how the dark nebula scatters the particles, the dust grains in these dark nebulae scatter starlight. Well, similarly, those same dust grains scatter that blue light, and that causes any star that has a complete spectrum to lose part of its blue spectrum. So when you see stars in these dark nebulae, they tend to look red, like this. See? Because their blue light has been removed. So you see them looking red. Yes, they could be red dwarf stars, okay? But in many cases, they may not be, and they will be just stars, sun-like stars possibly, that are reddened. This is a reddening that's being caused by this scattering that you can see clearly with the brighter stars, but not so much with these fainter stars. All right? But the scattering is occurring, and it's causing the starlight to be reddened. All right? Same reason the sunsets are red. Same thing. Okay? And this is nice. We've done 11 of these 45-second shots. And we'll get to 15. We're not going to go to 24. But we're doing it at 45 seconds at 400 gain. Now, 400 gain, sensitivity of the sensor, okay, guys? So that means that the sensor can be set to 0, in which case you might think that you see nothing, but there's a base amount. 0 is more like what your a very small telescope might see. These small refractors have very, very high focal length and very, very low light gathering power, so they don't really see a whole lot. Now, this gain on this particular system can go all the way to 560, and we're at 400, so we're pretty much up there. So doing more exposures allows us to actually get an image that is, well, a little more softened of noise. We don't want the noise in here. And any of the noise that is left in here, like you can see in here, see how that looks like mottled color? That's noise, and I can remove that. I can get rid of all that stuff and replace it with proper data, and which I will do. But you'll notice around this nebula, all right, because we're doing it at a higher gain, notice how the embryo nebula is actually within a dust cloud. See this? See this dust cloud around it? This is what's in here. If you want to see what's really in here, let's do what I call a massive push. Okay, that's what's there. Okay, all this dust. What?
So that's interesting.
Right? Yeah, all this dust is there. Let's just do a color correction to make it more clear. Look at that. So now you see how much dust is actually in this area of space. Right? And so through a telescope, whereas you might see, let's do it this way. Let's show you. You might see this through a telescope. Say, oh, look at that. We can see some little emission nebula and some reflection nebula. That's cool. What you're missing is all of this that's there. You don't see the rest of this, but it's there. You know? Not bad. So here comes our 15th exposure. And actually, I'm going to wait one more second. So I'm going to go down and see if we can get to Casper. Casper is down here. Let me actually find. Oops, that's the wrong thing. Let me find Casper. Yeah, that's where it is, and that's probably might not be high enough yet. Let's see where we are. 45. Oh, it might just barely be high enough. Oh, we can probably try it. Let's try it.
Gabriella asks, what are the white streaks?
Yeah, the white streaks, Gabriella. Good call. Those white streaks that you saw are an artifact on my sensor, which we removed digitally for now. But when I go back out to do maintenance, I'm going to open the camera up and get rid of them. We cool the sensor. If you notice down along the bottom there, you see down here, the temperature of the sensor right now is minus 20 Celsius. Okay, so you ultra cool the sensor, but those streaks that occurred over time, and they're condensation streaks that became frost during one session on a humid night, probably, which is very, very rare out in the desert. And then they stay there as an artifact, and you have to open the camera up and clean them. And the camera actually has 4 desiccant tablets inside, and those desiccant tablets remove the moisture from the inside of the camera, which is sealed. And so, excuse me, those tablets have to be recharged. So I got to go in, remove those tablets, put them in a microwave, and run them for 2 minutes, and then take it and get rid of that. Take it and get rid of the moisture. So that'll help a lot. All right, so that got us up to how many? 18. Okay, that's good. So we'll pause it here. Look at that nebula. Isn't that beautiful, guys? No. Once again, this is the beautiful Embryo Nebula. Throw that out there. Okay.
Marcin, how do you do it? Very carefully.
Oh, okay. How do you clean the camera without avoiding contamination? That's a very good question, Marcin. I never go inside the camera sensor window. There's a sensor window, then there's an overlying window. I'm going to take off the outer window, and it's inside that outer window where you see these 4 desiccant tablets that I have to bake. All right, and then the window on the outside, that's where this condensation will be. And I'm going to wipe that off, clean it with a special cleaning kit, and then I have to clean it, the other window on the other side as well. And then we'll be ready to go. And those will be gone, and I will be a happy camper. Now, I could probably get Marianne or Tara to do it, because it's something they could probably do. But I want to do it. And I'm probably going to try and get out there in January to do it. Keep in mind that I'm in the northeastern United States in Connecticut, and the telescope is out in Arizona, 2,500 miles away. So it's not easy to just run down and do it, you know. So I'm running it from Connecticut. So everything you see is being run from Connecticut. So that right there, that telescope in that building is, you know, half a continent away. Actually, almost a full continent away. Oh, this is nice. I'm glad I waited the extra time. Okay, I'm going to save this now as the embryo. So I got to name it.
It's a cool image.
Yeah, it's going to be pretty all processed, I'll tell you that.
Can you zoom in on the center?
Yeah, I will, actually. Good idea. Yeah. I can't wait to do Casper at 400. Alright, so going in from dark clouds, going to here. Look at, there's a complex of little nebulae in here that are emission nebulae. Look at those.
Sort of out irises the iris.
In a way. Let me take the name out. There you go. Cosmic Ray says, get a couple of new desiccant tablets to use after the old ones explode in the microwave. Hey Ben Izabela, how you doing? I saw the tablets being baked in the microwave, and they said there's no problem with that. So I will try it, but before I get out there, I'm going to have new tablets with me. You know, I actually have some here, but I'm not going to use them because they're actually beads and not discs. These are discs that we're going to get. Oh, look at that, man. Okay. Enough. I got to get out of this and go to the next item. All right. So there's the whole cloud that we're looking at right there. And, oh, look at this. Holy cow.
Mm-hmm.
That is new.
It's been there the whole time.
I know, but look at this very interesting, remarkable little object here. Wow. All right. Well, you know what? We may be coming back to this. Not tonight, but at some other point. We will be coming back. I would like to image that and specifically. Okay. So we should now have this up on our database. And if you want to go look for it, you can again go to SkyTourLive.com and head to our it'll take you to our server, which is called our OneDrive, right? And I'm in a supernova right now, so I'll be right there with you. And here we go. All right, so give you an idea. Okay, this is the directory it's going to take you to. Okay, 12/16/2022. That's today. And if we go in there, you can see the Perseus Cloud Mosaic. Here are the 4 images we just took earlier. Here's the Embryo Nebula we just took a moment ago. And it's still being uploaded. You'll see it there shortly. And I don't know what this is. But, oh, I know what that is. That was a mistaken capture. But, like, for example, so you see these directories, you drill down, okay? So you'll see them by name. Embryo Nebula, Perseus Cloud. You go into them like this, and then you see the time, right? But you click on the time, and now you get to the data processed, and this is the stack of the raw data. If you want to take it and try it out yourself, you can take down the stack. It's in FITS file format, FITS, right? And if you want to just get pretty pictures, then you just come in to here, and you can download the pretty pictures. Right? This is exactly as they were out of the camera when we took them down. So there you go, and away we go. So now, what that tells you is that these images are on their way up there, and we're very pleased about that. And we'll clear this now because we're going to be coming back at some other point, and then we're going to go to our night vision mode. All right, here we go. All right, and night vision mode is on. We'll fill the frame with the object. Now we'll try and see if we can go here. Let's see if we can go to the Casper the Friendly Ghost. I'd like to know we could. There we go. Telescope's moving. You can see it doing it. Alright. Oh, that's going to be close. Still clear. Oh, there it is. I think we made it. I think it's just above. Just above.
I didn't see where the embryo nebula was in the sky.
Oh, okay. It's right near the Perseus cloud. I'll bring it to you.
No, that's fine. That's fine. I just wanted.
Right.
Carry on.
Ray says, take a flat frame so you can take out the condensation artifacts. I could do that, and I have. In fact, I am doing an auto flat frame with every image that we take. So we are doing that. Let me come down here. All right. And as you can see, it says apply flat down here. And you can see there's one in here. That's the frame I took specifically with the artifacts. But it doesn't work as well as you would hope. So nothing is better than actually just cleaning the sensor. So I guess that's the best thing to do, and that's what we're going to do. But that's a good suggestion, Ray. So now we're going to come over and we're going to go south a little bit, because I happen to know that this object isn't just this. It extends way down here, and it's really beautiful. So this I think is probably good.
Makes me wonder if we could catch the boogeyman tonight.
Oh, wouldn't that be neat? She doesn't.
Pretty general area of sky, isn't it?
Yeah, I think it's a little more south though. This is the limit. This is pretty much the limit for us right now. There's a beautiful nebula over here that you'll see too. And I'll show you that in a minute. Okay, there we go. And I'm just gonna take us west a little more. We also see over here a little haze. You're gonna see part of Barnard's Loop is gonna show up too, possibly. It's really pretty, and there's stuff down here. Let me just take a shot. Head over a little more. 2 knocks, and then we will set this to come up here. Set this to 45 seconds again at 400, and we'll search. There we go. And now we're guiding, as you can see up there. That's good. Okay, and we're stable, and away we go. And now we're going to go into our live stack. This is an area where there is another reflection nebula with a very prominent dark lane going through it, dark material up in the front. And it is really, really something. Sam S says, the Connie Willis. Did you hear me on Connie Willis' show on Coast to Coast?
No.
Okay. I did that show while I had COVID out in Denver. And I could breathe okay, but I was definitely winded. And when I listened to the show, I was afraid I was going to show, but it wasn't that bad. Oh, it looks like I did not wait long enough. We'll have to clear that. Start again. I might also have, because of the angle it's at, I think the guide scope should be able to see. But I think I just didn't wait long enough. for it to stabilize. Izabela says, somehow the Casper, the Friendly Ghost Nebula, looks to me like a hobbit's house. I can't deny the similarity. Okay, let's see if this is better.
Was the altitude a factor for you when you were in Denver?
Yeah, I got altitude sickness, of course. But don't forget, but see, I got altitude sickness because I was at 11,000 feet for 2 days prior to that. And I was already getting sick. And the COVID was already kicking in. So I ended up really having a problem.
Where were you at 11,000 feet?
Oh, one of the passes. I want to say hi to Connie Willis. And here is she. She is Connie Willis is here. Connie, how are you? She said, you had COVID the night we spoke on together on Coast? Yes. I had COVID while I was doing that appearance with you on Coast to Coast. I'm glad you thought I did great. It's so nice to see you, by the way. Folks, note Connie Willison here. She's one of the hosts of Coast to Coast AM. And I had a really good time with her on the radio. It was wonderful. Well, you know, Connie says I had no idea that you had COVID. Well, that's not the kind of thing you announce, because then everybody's just going to think of that. You know? And it was okay. It was a lot of fun, and I had a great time with you, Connie, and I really, really thought it was nice. Actually, I was thinking, too, of wouldn't it be great if I could get you to come on one of our SkyTour live streams and hang out with us and talk to us for a little while. I thought that was pretty good. Yeah, she said, you do not sound sick. Well, before we went on the air, I sat there and I just started enunciating some words to make sure that I wasn't sounding like I was sick, you know. So tell me your schedule, Connie, so we can get you to come on with us. That'd be a lot of fun. You know, I could probably, well, you know, I think it's cool. I'd love to have you on. It's nice to see you here. This is the first time you've been here, as far as I know. Unless you lurk in the background, like some people do, and then they leave a message when I'm about to go. And it's like, hey, you were here the whole time? Yeah, I was just hanging out. Oh, look at this. This is beautiful. This is actually called Measure 78, I think. Also known as Casper the Friendly Ghost. It's a reflection with some emission, but it's mostly dark nebula. Oh, I'm glad you came out, Connie. Connie says, I happened to see you were live, and I went, nice. Okay, Connie. We'll email, and we'll set up a time. Does that sound good? I mean, it has to be clear, too, right? But Arizona has 300 clear nights a year. So I'm pretty confident we'll find a good time. And we'll soon have 3 observatories to run, so there won't be any excuse for not having a night with you. Marcin Johansson says, have any of you ever used a software Space Engine? Absolutely. I use Space Engine to teach astronomy sometimes. I also use Space Engine personally. The three-dimensional rendering of the universe is gorgeous. The nebulae aren't proper, but you know what? That's okay. You know, they don't have that data, and that's cool. That's cool. So yeah, this is looking great. And Izabela says this looks like a hobbit house to her. But look at let me zoom out a little bit. Okay, so you can see a little bit more. Look at this material that we're in again. More dust. It's everywhere. This is the stuff from which life springs, okay? This dark dust in here is very, very cold, as Daryl mentioned earlier. It's a few degrees Kelvin, all right? And it can be as dense as about 75 to 100 molecules in a cubic centimeter, whereas we have, of course, something on the order of 10 trillion molecules in a cubic centimeter in air. Okay, so or just around there. And so we find that this area is not very dense, but it looks like it's very dense. It's not. It's not very dense. Marcin Johansson says, heart-stopping photography, by the way. Well, I hope it doesn't stop your heart. But if you're talking about what we do, thank you, Marcin. That's really nice. Yep. Kanye, are you on Coast tonight, if you're still listening? Incidentally, in the upper left, remember I talked about Barnard's Loop? That's that long... It's an ancient supernova that occurred in the Orion spur, the Orion realm of our galaxy, and it makes a large object that you can see with longer, wider angle shots, and we can see a little edge of it right here. That's Barnard's Loop right there. They're all part of it. Yeah, there it is. Yeah, and so we have soft emission nebula in here, also mixed with dark nebula and reflection nebula right there. So that's really cool. Outstanding stuff, man, let me tell you. Let's zoom in, shall we? First of all, we're gonna say this what it is, just throw that out there. There you go. An inverted 8 below and on the left. See, Gabriella says, I like the inverted 8 down below on the left. Down below on the left. Where are you looking? Are you looking in here? I want to know where the inverted 8 is. Look at these things here. Oh, stunning. Thank you, Cosmic Ray, for providing us with the statistics on this object. Connie Willis says, when I asked her if she's on Coast tonight, she said, not tonight, we'll be on Coast Christmas Eve, Christmas Day, and New Year's Eve. All right. Taking on all holidays for the team. Well, you know what? Taking one for the team is what it's all about sometimes, right? So I think that's pretty cool. Well, maybe we can get you on with us here at some point, either before or after the holidays. Your call. I sent you an email. If you want some of these pictures, SkyTourLive.com, you can go there. And we also have some hyper-processed ones that I'd be willing to send you to if you want. Let me know. Izabela says, when I become a ghost, I'd love to live in this nebula under the bridge. That's funny.
She could be a troll.
Yeah, that's right. That's what I was thinking. I didn't want to call her Izabela a troll. She's a sweetheart. She does so much good stuff for us. As I said, she's responsible for all the tables of contents you guys get for every video. She makes the marks. I put the table of contents in after she makes it, and then you get chapters that you can go to and just say, oh, Casper the Friendly Ghost, let's go there. You don't have to wade through it and see it, Yep. Isabella says, oh, this would be great to have Connie Willis here. Sure. We'll bring Connie in. She's a wonderful person. Talented person. Marcin says of Isabella, She'll grace the nebula by watching over any life that develops, like a friendly watchman. Well, how do you know that she'll be friendly? She might not be friendly. The nebula might change her. Yes, Cosmic Ray, that's a good point. There are a number of Herbig-Haro objects that are known. Herbig-Haro objects are very young stars that are putting out copious amounts of radiation, and there's a number of them, 17 known here. We've got a number in Orion as well. There's at least 2 in the cave down in the southern area of the Cave Nebula. Okay. Walter Kakibinski, how you doing? Nice to see you. He writes, "Hey Mark, just started watching. I'm a blue rocker a la Connie Willis." Fantastic. Fantastic. Good to have you here. Good to have you here, man. Thank you. Make sure you subscribe. Okay? Subscribe. It's all free. You know, we don't charge for what we do. You know, so, you know, the old ding ding ding, you know. Subscribe and like, right? Thumbs up. Give me a thumbs up. You know. JSCO, I haven't zoomed on it yet. No. But I will. He asked if we try to zoom. Okay. Guys, make sure you read Cosmic Ray's notes, because, you know, by and large what he writes is correct. And I like it. Connie Willis says, "Excellent. My other personal show, Blue Rock Talk, is Blue Rock Talk. So if you join, you're a blue rocker like Walter." Okay, I gotcha. So that's why I didn't know that, Connie. Thank you. But I knew you had the Blue Rock Talk. I knew you had that as well. You know, I'm a blues guitar player. I mean, I just, you know, I woke up in the middle of the night after taking lessons with a guy who played with a number of really high-end folks, you know, and when I found out he played with these guys, it's like I couldn't take lessons from him anymore. I was all nervous. But I woke up at like 3 in the morning one time, and it somehow, the fretboard on the guitar was always very strange to me. So I woke up at 3 in the morning, and it was clear. It was clear as day. I realized what was going on. I came downstairs, sat down in this chair, pulled up my electric guitar, and I started playing all the way up and down the fretboard. And now any song that comes on, no matter what it is, I can play to it. It's like magic. It's a magic thing that happened while I was sleeping. It just shows you that you're constantly working at things as you sleep, and I was. Maritza Morales, how are you? CS es hermoso. Es hermoso. Gracias por sus complementos. Thank you. Yeah, it's Izabela put up Connie Willis, the podcast. Oh, is that her Blue Rock Talk? Excellent. See that, Connie? Here, that's what's good about the people that are in our chat and part of SkyTour LiveStream. You know, they welcome everybody and they promote everybody. You know, just like I do. So, you know, one good turn deserves another, right? And that's what we do here. And you know, look at this stuff. This is infectious. I mean, this is just beautiful. No, I don't mean you're gonna get COVID from it. I mean, it's just infectious. It makes you love astronomy. You know. Now, we've been taking pictures of these for years. And Cosmic Ray said, "Why are we always taking pictures of Orion?" Well, let me tell you. Because these are big, large objects, yes. But if something changes, if a new star winks into existence, we may have captured that. And so, by going back and looking at years past images of the Casper-friendly Ghost Nebula, we compare them with a blink comparative. You know, it shows you different images, one after another, and you'll see the differences stand out to you right away. We could find a young hot star that just winked on this way. So I think that's pretty cool. So that's part of the reason why we do this stuff, is to see these, you know. So really cool. All right, thank you, Izabela, for putting up her links. That was very kind of you. Okay, so let's zoom in now. JSEO said, why didn't we zoom? Well, he didn't say it that way. I did. I was waiting for more data to come in because we are at 400 gain, and 400 gain requires that we have a lot of these images stacked to see them close up without any real noise. And now you can see that right here. Look at that. Here are the stars powering this guy that have the blue light that is being scattered by the dust in this nebula here. Here's a dark lane. This is in front of all this, and you can tell because it's dark. It's silhouetted. So it's up here, and that stuff's back here. Okay. You can see it peeking out from behind here in this end. And I'll just get rid of that right now. We don't need this guy right now. Let me pull that out of there. There we go. Hi there, Robin Rich. Another blue rocker. Awesome. Awesome. Oh, that's very cool. You subscribed since Connie Willis mentioned us. That's it, you know. Excellent. You're still there, Daryl? Wonder why it was.
Yes, I'm here.
Okay.
You're on a roll.
Oh, that's no problem. You always can interrupt, you know that. I just learned that dead air is an enemy of any broadcast. See that, Connie? You got another blue rocker, huh? Yeah. And it's because of you that they're here, so I thank you from the bottom of my heart, Connie. Because of everything you said, you got a lot of people for us. That's really nice. Very cool. Okay. Yeah, JSEO, this is live. We're looking at this live. You know what, Daryl, I noticed these stars in here, these probably B-type stars,
Yes.
are very, very well defined in this image. Normally, they get kind of overblown, but they're actually quite small. It's very nice to see them, and I think it's because of the trade-off by going to a higher gain, longer exposure. The higher gain has allowed more of the nebula to come through in time to sort of counterbalance the brightness of the stars.
You were talking last stream about wanting to shoot at a lower gain. You thought it gave you a better image with less noise.
Well, you get less noise, that's correct. But I'm feeling that the higher gain with a longer exposure will allow us to see more detail and have that noise eliminated as well. And as you can see, we're at 400 gain. It's almost as noisy as we can get here, right? But if I zoom in, all right, take a look again. You'll see how we still see some noise in here, but that we can eliminate with no problem.
I looked at your weather forecast for Arizona earlier tonight and said you might hit below zero, or not below zero, below freezing.
Mm-hmm.
You think you may need to refocus at some point?
I'm using temperature compensation here. I came up with that equation, and I've watched this focus change as the night's going on. So I'm still getting some pretty tiny stars, so I think we're good. But one thing I'm not doing is I'm not doing enhancement. When I do enhancement, okay, I'll do an unsharp mask. It'll sharpen stuff up. You see more detail, okay, and you see a lot more detail. And clouds become more detailed. Like this is now more detailed in here. Turn it off, and some of that detail is going to go away. But these two stars are visible now. But if you do an unsharp mask here with a radius of this is 1.1 pixels, guys, then what's going to do is it's going to really overblow those stars. See? So we could just lower this, all right? And if we bring it all the way down to 0.5, we have our stars back, and we don't have as much sharpening. But this gives us a good starting point. But I'm gonna bring us back up to where we were. We'll go to 1 pixel. 0.94 is good. I'll just turn it off for now. Really pretty. Izabela says, I see a lot more detail than ever, especially in the dark cloud. Yeah, it's true. We're seeing more, and the reason is because of the increased gain. You can see much more detail in here than we have before. You know? The processing steps are not shown in Ray's asking, when you put an image in database, are all the processing steps shown there? No, you're just seeing the final image. Like, okay, we've got 28 stacked here, so we're gonna say pause here, and I'm going to, well, I'll leave it going while I'm doing this, while I'm renaming it. Okay, and we're gonna call this Measure 78 M78. Okay, and it's a reflection nebula. All right, and that's what it's reflecting, RN, reflection nebula. All right, we'll let this one come in. This will give us 29. I guess I'll wait one more and just go to an even 30. We don't have to, but I will. Okay.
Marcin, to answer your question, I saw on the tube many years ago, I don't remember where, there was some old guy out in the Arizona desert. He had a tractor. He took, I think it was a railroad tie, and he wrapped wire around it, made it a great big huge electromagnet. He just drove that thing around, dragging that tie behind his tractor on the desert floor, and collected meteorites.
What was Marcin's question?
Going fishing for metal meteorites, Daryl.
Oh, okay.
Connie had asked where to go to collect meteorites. I said Arizona desert, take a magnet with her.
Yeah. I'll be out there again soon, Connie. We should meet up and do some meteorite hunting. Okay, this is beautiful. So here is an example I'll show you. This is what you get when you actually see the image exactly as seen. This is what you're going to get. You're going to get this image out there. And it's a full resolution, by the way. All right, so this is only 75% here. You get 100%. So your image will be this big, and you're going to have a lot more on either side. All right, so that's how that works. It's wonderful. Okay. Now we're going to go to auto mode here. There we are. Okay, and now we'll clear this because it's out there. It's on its way up. And now we can go back to our 1 second shot and go into night vision mode. There's a night vision mode. Let's see what else we can see at this point. Something parallel. Ooh. Oh, maybe. Let's see. Yeah, we can. All right, I showed this last time, but I'm going to show you this time as well. This is probably the unparalleled beauty of the evening. Very cool, Connie.
Marc shared a post-processed image of the rosette the other day, and I liked it so much that I made it my new background on my computer.
That's very cool.
And that's saying a lot, because I hadn't changed the background on my computer for about the last 3 computers. At least 10 years, probably more like 15.
Wow.
And it was a wide field view of Orion before.
Well,
but I asked him to send me what I got was a download, and it wants to sit off center on the background, so I need to do something about that.
well, you can just take this one if we come out good. This one, you know, this typifies what clusters do. This is a young hot cluster, and you'll notice it looks like a dark round circle in there. That's because these hot young clusters have such copious stellar winds pushing out that they're actually creating a cavity in the gas, yet they're ionizing a lot of the hydrogen, making it red. And of course there's snaking lines of black dust and in here that make the dark nebula lines in here. So let's do 45 seconds now, and you're going to see a lot more detail even than the other night. All right, the other night was spectacular, but this is going to be even better, I think. Okay, so we're stable and guiding well, so we're going to cut this now and go in.
Why will it be even better?
Because we were at a 100 less in the sensitivity the other night.
Yeah, the gain.
Yep. There's a Rosette Nebula, and we're gonna see this now. And when you see this come in, for those that haven't seen this, and even for those that have, this is one stunning nebula. All right, so we have 15 seconds for this image. Now it's building up on this sensor, and it's gonna be read out all at once, and that's when we see it. All right. Bill New York streams in Newburgh, New York. Look at that. Now that is a stunning nebula. You can't, without a doubt, that has got to be one of the most beautiful nebulae there are. Let's see if we can do a little processing to show us a little better darkening here. Here we go. And now we'll do a color correction, which is making it look a little redder because the color is correcting to red. So this is the rosette, and this is, by and large, this is the best example of a cluster that is carving out a cavity, as I mentioned. Okay, and as you can see in our past shots, here's a little hints of stuff out here, but now we're catching all this other stuff out here, that like out here. Okay, we never caught this before. We're adding, this is all new stuff on the outside edges here.
Frau, this is another stellar nursery. Star cluster formed inside the gas cloud.
That's right here.
It's now hollowing out the inside of the gas cloud from the pressure of the starlight, the radiation from the stars. It's also lighting it up.
Yeah, I know it doesn't seem like that's even possible. What's even worse is that it's several light years across. That means that the light from these stars is so intense that it can cause hydrogen light years away to still glow. Now, it's not easy to ionize hydrogen. It requires a high enough temperature, or in the case of a nebula like this, a high enough energy of that light. So that would make this happen. So again, this here, put it out for a moment. This is the Rosette Nebula. It's an emission and not a reflection. I don't know why that was in there. Oh, I know why, because I left it in there. This will be a stellar nursery. Okay. Yep. And not to keep blocking the screen with it, I'll pull it off. And just because we're going to just go now full screen here. All right. And now we're full screen. You get to see all of it. And as I said, this is that young cluster. And this whole area is hollowed out by these young stars. Stellar winds pushing outward, pushing out like out here and out there, okay, in all these directions to kind of hollow out. And it's going in 3D too, so it's coming towards us, it's going away from us. And this is the thing that makes it so interesting, is that the universe is in 3D, but we just see it in 2D. It's a 2D projection, you know. So again, let's while we at it, why don't we zoom in here just to show you something. Okay, if we zoom in on the right side of this, okay, you'll notice that we have these dark, sinuous clouds in here. Okay, those are dust clouds, and they're each the thickness of a fraction of a light year anyway, probably more than one in some cases. But then you'll see these dark dots. This is not dust on the camera. These dark dots are special objects known as Bok globules. Now, Bart J. Bok was a famous astronomer that discovered these dark globules. He called them Bok globules. And these Bok globules are gravitationally condensing areas where there's either going to be a star or a star in a planetary system. And when I was getting my degree in astronomy, Bart Bok was actually at the university, and he taught some stellar physics to us, and it was a very enjoyable class with Bart Bok. It was just amazing to see the guy that found Bok globules, and the guy that actually revolutionized our thoughts of how the universe forms stars. It was amazing to see him in front of us. Bart Bok discovered these globules, oh gosh, I think, if I'm not, I could be wrong here, but I think it was in the 60s that he started theorizing that these Bok globules, these globules were stellar formation sites. But don't quote me on that. I don't know why I thought that. I'm just going back to what I seem to remember.
60s or 70s, I think.
Yeah, I think so. Okay, so now if we move down to the lower left in this Rosette Nebula, you see other things. You see some really interesting objects like this. See that right there? That's what's called a stalk. It's also known as an elephant trunk. It's also known as a pillar. And you've seen the pillars of creation that the Hubble Space Telescope took. The Hubble telescope took that image and it was taking a picture of an evaporating cloud that was evaporating because of a very, very bright cluster, hot cluster, whose ultraviolet light was, and stellar winds were evaporating the cloud of gas around it. And that's what's happening here. We're seeing this gas all around this pillar is being evaporated by these bright stars. That starlight is pushing toward here, and it's pushing away the gas. And why is it leaving a stalk? It's leaving a stalk, and we should zoom in on that a little. It's leaving a stalk for one very important reason, right? And that important reason is that top of the stalk, okay, this area right here, okay, that area right there is denser. It has material that's much more dense in there. And so with this density, it allows the stalk's end to remain intact, and thus anything behind it is protected from that stellar wind that's blowing down this way from that cluster. So that's why you get a stalk. And over time, they may break off in the middle and just be like a globule that condenses into a solar system, perhaps, or a planetary system with solar system, star system. But we see stalks all the time, and we look in the universe. So be on the lookout for them, because we also see these in a lot of clusters, right? And they're usually aligned with the cluster that started it all. That started them all.
Is Bart Bach still alive?
I don't believe so. He was old when he was instructing me.
He first observed Bach globules in the 1940s.
Okay, so it was
40s.
40s.
And he first published about them an article in 1947.
Okay.
I didn't realize he was that old.
Oh yeah, he was. He had all gray hair, and he was, I think, in his early 70s when he was teaching me. So he was an old guy. Either that, he didn't age well, I'm not sure. Hello, Alice Pooper. I didn't say hi to you. Good to see you. But this is just a beautiful sight, isn't it? Back out and show you the whole thing again. Look at that. Wow.
You had really punched up the red on the one you sent out a couple of days ago.
Yeah, this is the raw red color out of the camera. I did make it a little bit more saturated with the red on the one I sent out. There's one on Facebook too that I talk about, and I show you the picture very much like this one. This one has more details in it than the previous one, but I did a nice little discussion of the Rosette Nebula and how it makes a cavity and all that stuff. It's one of many like this. Pretty cool. Now, next to this one, and we have, I think, enough to save. We've got 13 stacked here. That's good. 13's a lucky number for me. So we'll pause it here and save it. I have it labeled properly. Okay, so now that raw file saved, and now the exactly as seen file is saved. And now what I'm going to do is take us to another location nearby. We'll clear this on the next run in here.
I saw the Rosette once by eye.
Oh yeah?
It was in a large telescope, and it was with a hydrogen beta filter, if I remember correctly. You could see it, but it was just this ghostly gray thing.
It wasn't bright enough.
Yeah.
Yeah.
Proud they would have been
brightness.
using black and white film back in the 40s.
Yeah.
Glass plates, probably.
Yeah, actually, for our parallax work that I did, we actually used glass plates too. They were the most reliable. Now with the CMOS sensor, the need for glass plates has evaporated.
Oh yeah.
Just like the pillars in the Pillars of Creation and in the Rosette.
Oh, if you watch those deep sky videos on YouTube, University of Nottingham, I forget which telescope they're at. They use several different telescopes. One of them's on the Canary Islands, I think. They're down in the basement. He's showing their old star atlas, which were a bunch of hanging pieces of film, which were copies off original glass plates of whatever sky survey was done at the time. And that's what they used to use. And he said nobody uses these anymore. So right. they just hang around.
Yeah.
And they made film copies of the glass plates just to save breakage or wear and tear on the originals.
Mm-hmm.
And it's one of those things where nobody used them anymore because it's all digital now.
But Daryl's not bitter.
Nah. Some call it progress.
Well, I think if we ask everybody watching right now if they'd rather wait for me to develop film or show them pictures right away, you know what the answer is going to be.
They want. It's like what Maximus said in the movie Gladiator. You know, are you not entertained?
Are you not entertained? Alright, we're gonna move over a little bit. So, this is the Horsehead Nebula. This is Alnatok. This is the Flame. We're gonna move a little north because the Flame has an incredible amount of detail in it that we had not captured ever before. And it's all out here as well. Obviously, it's called the Flame because it looks like a flame. Alright, so let's wait for our guide star to be found. It takes 14 seconds to find the guide star, 11 seconds to get the guide star, and then 2 seconds to lock onto the guide star like this, and another second or so to stabilize. Now see, sometimes it'll do that, so I gotta wait for it to actually find the guide star. Yeah. Not sure why it's doing that, but while we're waiting, I'm going to show you something else.
Ray, I did astrophotography on film back in the 80s and 90s. And yes, and back then, you know, I'd shoot a roll of film. I'd be happy if I got one good image off of a roll of film.
Oh, yeah.
And nowadays, all you have to do is hit the delete button and recover your space on your hard drive.
Okay, this is our all-sky camera. You'll see the view here. So there's the all-sky view. That's bird poop on our dome of the all-sky. And this is the horizon all the way around. And there is the winter Milky Way coursing right over our heads. There's Orion. Okay, right there. There's the belt and the Orion Nebula down here. We're actually right here at Alnatok, and we're hanging out there right now. These are the lights of Phoenix, almost 70 miles away. But it's a sensitive camera, so the camera sees it. You don't see it with your eye. And so we did the Casper the Friendly Ghost, which is right about there. Okay. And we did the Rosette, which is right about there. Okay. In fact, I think you can actually see it. Let's see if we can see it.
See the entirety of the winter circle there.
Yeah, you can.
Sirius, Procyon, Pollux, Castor, Capella.
Yeah.
Aldebaran, Rigel, Jupiter over on the left.
Way over. Yeah.
Mars just right of center.
And that right there might be the Rosette Nebula we just took. Might be right about there, or it could be this one. I'm not sure. Yeah, this is Mars right here. This is Aldebaran and the Hyades. Yeah. Okay. So there. So you can see we're just checking the night sky out there, make sure we have a good night, and we do. So we'll minimize this. And we've been guiding for a while here, so we're going to do 45 seconds here on the Horsehead. And we will go into our stack. And you'll see why in a minute. You'll see why I got us to have the Horsehead over to the right. So we'll clear this now. But first, let's just take one last look. Let's go looking in here. Beautiful. Pillars are beautiful in there. Okay, and we'll clear it now. Cosmic Ray says, hand guiding for 1 hour film image is something you got to do. Meaning that I have to do it, or that I was privileged to do, because I had done it. I've actually guided exposures for well over 3 hours.
That's crazy.
It was, but I got the great result. This is a Horsehead. Look at this. Okay, we'll zoom in on this, don't worry. But look at the flame. The flame has all this additional data out here that's, wow, it's just so cool. Right, and of course we have satellites moving through the field. And in here, the reason is because there's a lot of modeling in here. A lot of dark nebula in here is sort of like an edge of the Orion molecular cloud complex. You know, this is Sigma Orionis, one of Daryl's favorite stars. And it's responsible for causing this hydrogen gas in this wall here, this molecular wall, to glow. And so that's why it glows the way it does. You also see fine radial streaks here. Not sure why they're there. They could be generated by electrical currents running through the nuclei that are causing them to possibly align with each other. And not sure, but it's really, really pretty. And if we zoom in on the horse head, we only have a couple stacked. But if we zoom in on the actual horse head itself, let's see what our stars look like. Oh,
Izabela, it takes coordination and patience. That's how they used to do it, was manually.
Yeah, I'm going to clear this because...
that's how Hubble did it.
Oh, yeah. And you know what? You can't be absent-minded. Go ahead.
No. Oh. No worries. It's just the way they used to do it. They didn't have the automation. They didn't have auto guiders. They didn't have computers.
We were the auto guider.
Yep. You had a so-called guiding eyepiece with crosshair in it. You kept your eye glued on the eyepiece. You tried to keep that crosshair on the target.
That's right. Looks like we got some wind out here tonight. Slight elongation in our star images. And that's due to the wind. A little bit of breeze. I found that aiming toward this direction does tend to make it have a problem, but from a long distance away like this, it still looks pretty, so we'll just leave it like that. But there's a lot of detail in here that's really cool to see, and let me see about the color correction too. Okay.
I still have my old film cameras. I bet I haven't used them in 20 years or more.
Really?
Yep.
Wow.
I wasn't about to spend thousands of dollars to re-equip on digital camera equipment, and you know the stuff seems to go out of date so fast that I just said heck with it. I bought myself a little. I've had 2 or 3 digital point and shoots, but that's all I bother with anymore.
Yeah. Hello, M. Turner and Luciana. How are you?
Can you excuse me a moment, please?
Sure. While Daryl's gone, I was actually guiding. I was doing one particular exposure, an hour and 45 minutes, and as Daryl said, you have an eyepiece you're looking in, and you have crosshairs. Actually, they look kind of like this right here. Okay, and you would get your star that you want to guide on. You put your star right inside that little square in there. And you press buttons, north, south, east, and west, at a very slow rate to keep that star right exactly there. And that was called manual guiding. Now, this telescope's doing it automatically. It can't account for the wind, unfortunately. But what happens is, when you have that guider, or guiding, and you're doing that guiding, as you're staring through an eyepiece, your eyes fatigue, and you reach a point where you can't see the star anymore. And you panic. Oh no, I've just been guiding for 45 minutes. I'm not gonna screw this up. And so you look to one side, look to the other, and look back, and the star is there again. And you gotta quickly make sure that you correct and move it. Well, I got so enthralled with trying to do it, so focused on doing it in a telescope that was a 24-inch Cassegrain, okay, in a dome actually, that as it was winter and it was probably about 20 degrees outside, I was in a fur-lined parka at the top of a ladder up at this focusing, up at this eyepiece, doing this this work. And as I did this, holy cow, I heard weird noises the whole time it was happening, and I didn't know what was going on. And I realized that it was getting harder to guide, and I kept having to push the button more and more and more to get the thing to guide right. And I did it. I kept it in. And when I got to an hour and 45 minutes of what was supposed to be a 3-hour exposure, I had to stop because the guider wasn't able to keep up anymore. I pushed the button and it wouldn't go back in. It wouldn't get into the reticle. It kept trying to move off, and I canceled that exposure before I would actually screw up after all that time. So I got a beautiful hour and 45 minute exposure. Well, the reason that it was doing that was because I'm stupid on occasion. And one of the stupid things that I did was I allowed the telescope to slowly move, the whole 2 tons of it moving over. And as it moved over, the ladder I was sitting on was pushed up against the dome, and it was crushing the ladder around me slowly but surely. So when I finally flicked the button to turn on the light, the ladder was wrapped around me like a glove, and I was like, oh no, I can't believe this. How am I gonna get out of here? Not only that, how am I gonna explain this? Well, I was in this big fur-lined parka, like I said, so I literally slipped through the hole. The ladder was all crushed around me. I slipped through the hole down the ladder and came out the bottom, and then pulled my coat out, put it back on, and the ladder was all crushed, in a perfect fold that had folded me in there. And I thought that was the most crazy thing that I ever did in a dome up there, next to doing some strange things to one of the other telescopes there. But that was a scary situation because I was trapped in that thing for about 15 minutes before I figured out how to wriggle out. So it wasn't really it really wasn't the best choice of, best plan, I should say. I should have thought about where the dome was going to be an hour and 45 minutes from there, and where the telescope was going to be. But it folded the ladder like it was nothing. Welcome back, Daryl.
Yep. There was a guy that got killed by the dome at a telescope down in southwest Texas. I forget what it's called.
McDonald?
Yes.
Okay. What happened?
He tried to walk out a door in the dome while the dome was rotating, and it caught him and crushed him.
Yeah. Well, in the larger telescope that I used there at this university, the telescope was a 20-inch Alvin Clark refractor. So the telescope was, a good 100 years old, right? Almost. Maybe a little more, actually. And it was in pristine shape. The glass was ground and created to a quality far surpassing modern telescope glass. And the whole floor moved up and down to meet that telescope. So it was a big elevator you're standing on all night long. And when the telescope was looking to something low on the horizon, the telescope was like this. Well, the floor was down here. If you're looking at me, they're seeing me, Daryl, you don't. And when the telescope was like this, it could be a full story above you. So you go and move that elevator up and bring yourself up to the back end of the telescope so you could use it. And it was a very interesting situation because more than one person would try to walk out of the dome But when the floor was up, then there's a gate that comes down. But if you forget to put that gate down, which was a manual process, you could literally walk to the exit in the dark and step off and fall 2 stories into the basement to your death. Okay, so that was a very frightening prospect. So having been frightened by the staff there about making sure that you close that gate so you will not be tempted to walk out, I never made that mistake, which is why I'm still here. But that was very frightening, and there was no real safeties. I mean, there's no reminders, closed gate, something like that, no flashing lights. Okay, it was just you had to know what you were doing. Look at this, Daryl. We're seeing some blue reflection nebula in amongst the clouds, what I was trying to get at earlier. And let's see if how much is here if we punch this up a little. Yeah, see that? Look at that.
Yeah.
This is the region, guys. We're in the region of the Orion Molecular Cloud. This is just stunning. Look at that. And this is punched up a little high, so I'll bring it back down. But man, that's really beautiful.
I was reading about Yerkes Observatory a while back.
Yerkes?
Yerkes, whatever. The one up in, where is it, Wisconsin? North Chicago?
Yeah.
The world's largest refractor telescope. I believe it was also a Clark telescope.
Yeah.
Largest refractor.
Is that a 24?
No, it's 39 or 40 inches, if I remember right. And there was some talk of them decommissioning that thing. The weather's so poor up there.
Yeah, well, I mean, they could move it to Mount Lemmon, would actually have a much better...
Oh, yeah, well, that's what I was going to get at, Shame they couldn't move that thing.
They could, it's just that they would need the endowment and the money to do it, and that's probably really, really difficult. So look here, guys. Look at this. You can see now in this region, you're used to seeing the horse head just sort of sticking out like that, and when you see the horse head, but now look at this. Okay, let me just zoom in on this. Now we've got 14 stacked. Look at this here. Remember what this is right here? Pillar, a stalk, and the star in here is evaporating, made a cavity around itself. See, and it's evaporating this stalk, and there's a dense area that's not evaporating, so the stuff behind it is maintained and the stuff around it is blown away. Okay, not so much visible here, but if you notice in the horse head, there's a few really interesting stars that are interesting to see. Let me just show you. Okay, in the horse head itself, you notice the top of the horse head is a lightish color. You got this frayed front of the nose, and you got a star in the snout. You have a star on the top of the head, and you have a star in the back of the neck. Very interesting. And you look at this, you can see how this Horsehead Nebula doesn't come out of this per se. It's actually in front of that. It comes out of another area up in here. See? This is all part of the same area. So it's really a very interesting morphology. Remember, we're seeing the universe in 3D. We're seeing it in 3D. Okay? So, this is gorgeous. So we have 16, and look at these reflection nebulae here. These are just beautiful. Just beautiful, and that's what I wanted to show you, and that's why I took the picture like this. Okay. Now, we're going to do one last object, and of course you know what it's going to be. And first things first, let's do this. And I'm going to call it.
Let me guess, 1042?
Yeah.
Be sure and shoot a short exposure to go with the long one.
That's exactly right. That's what I'm doing. Alright. She turned me into a newt. I got better. Remember that?
That's why I said it.
Yeah. I got. Oh, I saw that. I thought so. I got better. It got better. Okay. So that's up there. That's the Horsehead Deep now, we're calling it. And we're going to save it with 18 images. Alright. And then we're going to save it exactly as seen. Pause it. Pop the stack out of there. Go back to our 1 second shot. Alright. We're going to be seeing a lot more in the region. There's so many more things to see here. But I'm just showing you the big ones for now. And I believe the Orion Nebula is going to be quite visible to us here in just a second. Yeah, so there we go. And did you know it was also called De Moran's Nebula? Moran's Nebula. That's M43. That's the top of Measure 42. We'll show you.
Say what?
Moran's Nebula. M43 had its own name. De Moran's. This is Measure 43.
I thought...
Moraines.
Okay.
I mean, it's probably moraines. There's moraines, and then this is Measure 42. Or in Daryl's case, Bill Murray eating a Baby Ruth or something, whatever.
You can't really see it in that image.
I could never see it in any image, but you know what?
Too washed out.
Yeah, alright. Alright, so...
And see, it's all part of the same molecular cloud.
Okay, Fantasy says M43 and M42 look like one nebula. And they are, as Daryl says, they're all part of that same cloud. But you also have to understand that there's a lot of dark nebula that block the nebulae behind them. So, for instance, this dark area right here, as we're about to see, this is all dark nebula. This nebula and this nebula are actually part of the same nebula. This is just in front of it. So, interesting the way that works, but let's show you how that works. Let's go in and do this. And we're going to do a 45-second shot. Well, first, you know what? I'll do this other one. I'll do the other one first because it's shorter. So let's do Measure 42 as our object here. Hold on. I can do it again. Measure 42. And it's an emission nebula and a reflection nebula, both. And we're going to do an exposure that's 15 seconds. Alright? And then we're going to do an exposure that's much longer. Okay? So let's come in here. There is the horse head that we're leaving behind. No. And so now we're going to come in here, clear this. And you probably missed that. So I have to wait for the next one. No, I'll show you, Izabela, when I come back.
Yeah.
Okay.
I'm kind of surprised.
This is the Orion Nebula. This little guy right here has its own designation. This is Measure 42. This is Measure 43.
Yeah,
and Measure 43 is Moraines Nebula.
Yeah, the little teardrop shape is M43.
Yeah. So let me.
I used to think the same thing. I thought Running Man was M43.
Yeah.
It has an NDC number, I think.
1977, I think.
Yes, I think you're right.
Okay. As it turns out,
Sharpless 2-279 or 279, blah blah blah.
I'm gonna do
NGC 1973, 75,
75. That's the one. Yeah.
77.
Was it 77? All right. So okay, I was right. I didn't know that.
Yeah.
I thought
There are three NGC objects there.
Okay, I'm gonna clear this because I'm trying to just get a image that will serve a purpose that you'll see later.
The brightest part is 1977.
Okay. Looks like I gotta go to like 3 seconds. Let's see if that works.
Excuse me.
Yeah.
The Running Man, or 1977, was discovered by none other than William Herschel.
And his sister.
De Moran, he actually discovered M43 well before Messier ever got started.
Mm-hmm. Okay, I'm at too high a gain for this. I'm gonna go to 150 and do 3 seconds and see what we get. I'll show you what I'm doing, guys. Okay, that's let's check the focus. Yeah, we have to, at this point now, I'm gonna refocus. Moving the telescope around too can change the focus a little bit, which is not that good. So let's do this. Let's go out here and let's get rid of the stack. Go back to 1 second and night vision mode.
Sam, yes, some objects have 2 or even several different catalog numbers.
Yeah.
They're numbered in different catalogs.
Yep. You have the Henry Draper catalog for stars. You have the Smithsonian Astrophysical Observatory catalog for stars. You have the Bonner Dirk Merstrung German for stars. You have Scalene Pliso for stars. You have Tyrian's Atlas for stars. All the way on down, and the first ones I mentioned, the first 3, those are professional ones that we use in astronomy. You also have a lot of stellar atlases and stuff out there. Like Uranometria was a good book that I have, which shows some really good stuff, has some articles in it, which are really nice.
I have the Scalene Pliso around here somewhere.
Yeah, I got it in the back room.
Yeah, that's a beautiful catalog.
It is. Actually,
Bill Murray.
Oh, come on now.
I do.
Yeah. Bill Murray. I don't see Bill Murray.
He's eating the baby Ruth.
I know you keep saying that. Okay, what am I doing here? All right. I am focusing. So here's what we're going to do. We're going to blast out of here. Come back to here. And I am going to take us out of focus a little bit. Give us something to work with. And you'll see now. See the stars show up as little donuts. That's because we're using a Schmidt-Cassegrain telescope with a center obstruction. And in our case, the center obstruction isn't a secondary mirror. The secondary has been removed, and the obstruction is a camera. Our camera's on the end of the telescope. It's inside this dew shield here. Okay, usually they're on the back of the telescope. Ours is up in the top in the front. It's in the front of the telescope. A very strange architecture, but it is very, very efficient and is tremendously valuable. It allows us to take an f8 photographic f8 telescope and turn it into an f2 telescope. Okay, so now we're gonna build our curve, and we're gonna dock it up so you can see it. So it's taking focus values, and it has to build a curve. And where that curve is lowest, that's the smallest stellar image, and that becomes the focal point. You'll notice that as it starts to shrink the star images, it finds more candidates to use for the focusing process. You'll also notice that it doesn't confuse the nebula with a star for this, so it knows enough not to do that. And that line indicates our best focal position right there. It's the bottom of the curve. Right. It's at the bottom of the curve. All right. And now we're going to go to best focus position. The telescope goes into focus, out of focus, then comes racking back into focus. And that's perfect focus right there. Okay. Now, I'm gonna take us downward actually a little bit, because I want to put the Orion Nebula at the top of the field. We won't see the Running Man tonight, but we're gonna see what's below the Orion Nebula, which is really incredible to see. So we're gonna do this.
We'll be looking at the middle and the southern part of Orion's sword.
Yeah.
The Running Man being the northern part of the sword.
Yep. So, okay, these little jogs are the only ones we're gonna do here. Okay. And now we'll set up, and we gotta wait the 14 seconds total time. We'll do our 45-second shot. And then, you think the nebula ends here. You're going to be amazed to see that it comes all the way down here. All the way. Okay, so we are guiding. And looks like we are in good shape right now. So we shall now head in and do our 45 seconds. Then I have to do one that's really short in order to get just the central part. Oh. Okay, my mistake. I meant to do this at 400. Okay, so we'll clear this and start again. Sorry about that. Okay. Alright, let's see what we get. Unfortunately, I've got to clear it. There it is, though. It tells you. You can see the nebula. It's like, wow. And there's a lot of stuff down here. So, and of course, you get the satellites.
Izabela, just going by what Wikipedia says, Demerans is, Demerans, whatever, 1,500 light years, and M42 is 1344 or something like that, I think. You know, two different people might have read the written the article, or they're darn close to the same, and they are in the same. They're different parts of the same cloud, molecular cloud. So if they're not the same distance, they're close to it, I would guess.
Yeah.
You'd say. As
As you can see, Orion being close to the celestial equator, the Orion Nebula specifically, we have 1, 2, 3, 4, 5 satellites. And these three are a trio. They go together, and they're probably the Navy's ranging system. Okay. And another one's coming in. I don't know if I want to pursue this while it's, with these satellites coming through. I'd have to get some times to actually do this without all the satellites going through. So
here comes another one over on the right side.
Yeah, that's what I just said. So we're gonna have to. I want to abort this but you can see there's a lot going on here. And actually, if we come in here like this, look at all the dust down here. Again, my favorite thing in the world is the dusty regions of the universe. So yeah. All right. Well, that's an abort right there, because we have to do this when those satellites aren't around.
Yeah.
So sorry about that,
You know
guys.
what? Give it a few years, and I bet you'll look back and you'll say this was the good old days.
Oh yeah. Well, we can't. Very true. Very true. All right. I'm going to get rid of that. Get us back to the 1 second here. Oh, holy cow, it's 1:45 a.m. Oh boy.
It's interesting to contemplate looking at that picture with all the satellites on it. If you turn the telescope off, the satellites would be pinpoints, and the streak would be the Orion Nebula.
I think we might get 2 sets of streaks, because I don't think those are geosynchronous. Geosynchronous satellites are much, much fainter. But I can do that, actually. Here,
That's okay. Take your word for it.
No, that's alright. I got you. See, look at it. It's moving right through the nebula right now. Look at that. Alright, so we turn off the tracking. Alright.
Comes another one over at the right edge.
Yeah. See that? Turn off the tracking. See how it's moving?
Yep.
Yeah. Yeah. So they're moving. Wow, that's pretty cool. Okay. Petita is with us tonight. Hi, Petita. I'm wearing my Pine Bush t-shirt. It's backwards, but I'm wearing it. Okay. I suspect. I mean, I would like to. I want to go here. So I'm going to go there. So this is where I want to go. I won't be able to do the whole thing.
Oh, which head?
Yeah, I won't be able to do the whole thing.
Which is chin?
Yeah.
Chinny chin chin.
Look at you, my pretty. Yeah.
Your little dog, too.
No, leave my Toto alone. Blast you, woman. Okay, let's see here. Are we in our position? I believe we were. Let's go check it out. Okay, we should be able to get this done. Let's try it. 45 seconds on that at 400, more than we've ever done. So this is actually going to be interesting to see. All right. Excuse me. And do this. And away we go. Oh, ho.
Turn into a pumpkin in 13 minutes.
Yeah, no, I'm, this is the last object for tonight. I just heard my son get up because he's actually getting up for work. He works for WFSB Channel 3, the largest television station here in the state. And he drives all over the state and goes out and grabs news. He's not a reporter, he's a cameraman. There it is.
Oh.
Okay, let's see how this looks. Wow. Dead center.
Yep.
Yeah, the color change. Alright. Let's see if we can get this.
The Witch's Head is illuminated by Rigel, is it not?
Yes, it is. Rigel's off to the left.
Yeah.
We'll just try and take a few of these and see what we get. Do some processing, just grab those and move them over. Wow, that's pretty cool. This may or may not work. Let's see how much material. Yeah, we got some information in there. That's pretty cool. I have to be all buttoned up here by 2 a.m., so we may not be able to go too much further. We'll revisit this, though. We're seeing more detail than we ever have, though, I gotta say. More detail up there, too. Wow, that's pretty cool. Yeah, I should have centered it up better and everything, but that's okay. This will give me something to play with. We'll just stack to 4 and then we're going to call it. I still have to put everything away, seal up the telescope and so forth, but I can do that. Okay. There we go. Okay.
Moon's going to rise in about 27 or 28 minutes from Arizona location, and
Yeah.
the moon is precisely at first quarter and
Last quarter.
or last quarter.
Okay.
Let's see. 1:56 a.m. my time.
Mm-hmm. All right. Well, there you go. So that's pretty cool. And I just want to say to all those joining us for the first time, thank you for coming along. I hope you guys enjoyed it. I know.
Sorry, that was this morning at 1:56.
Okay.
Anyway, carry on.
No problem. But as of now, you hear that music, you know what that means. It means that you have done it again. You have. What have you done today? Let's see how much time you've wasted today. All right, let's look. It's you've wasted 3 hours and 5 minutes, guys. Okay, 3 hours and 5 minutes, looking at the beautiful night sky. I mean, who could say no to it, right? It's just beautiful. Thank you, everybody, for coming out here. I want to thank all the people, especially those showing up for the first time in the chat. Thank you so much. Please subscribe, say hello, and if you have any questions, send them in a message. You know, go here, SkyTour LiveStream, SkyTourLive.com. I mean, you have a link to SkyTour LiveStream, what we're seeing tonight. You have a link to the database where you can actually get all these images yourself. And so I think that you guys have plenty to play with. You can get photographic prints if you want, canvas, metal, prints under glass, framed. We have that service up there too if you're interested. So they make great Christmas gifts, let me tell you. Woohoo. Anyway, I will see you guys the very next time it's clear. And in Arizona, we can guarantee a lot of clear nights. So, Go ahead, say it again.
Good night, everybody.
Wow, well, there we go. All right, folks. Have a good night. Talk to you soon. Remember, when you go out, keep looking up. See you later.